Welcome to virtual GED class. Today we're continuing our discussion of the geometry that is on the GED test with a discussion of perimeter and area of composite shapes. So I've told you guys before, but I'll tell you again. The GED subject or the GED testing service loves to scold adult education teachers like myself about not teaching you guys perimeter and area deep enough. Like we teach you the basic concepts, but then when you get to the types of problems that are on the GED, y'all freeze up and freak out. They tend to be of a higher complexity than just find the perimeter of this rectangle. Okay, I wish it was that simple. They're not. So today we're going to look at one complexity that could happen in the perimeter and area, and that's the idea of composite shapes. In order to do that, let's just do real quick little synopsis review of what perimeter and area are. So we've got Serenity here joining us today. Serenity, do you remember what perimeter is?
I believe it's around.
Sure, you could say around. The perimeter is the distance of the line around a two-dimensional shape. And I like that you said around, actually, because most of our perimeter word problems say something about in round or enclose or this language that tells us around. And then let's contrast that to area. Area, on the other hand, do you remember what that was?
I think it's inside.
Yeah, a lot of students use the word inside, and then I always end up scolding them, and they're like, why do I ever answer any of your questions, Kate? The reason why I scold them when they say inside is because when you guys talk about a 2D shape versus a 3D shape, what you mean by the inside is different. So like if I put this box at you flat, it's a 2D shape, and what you mean by the inside is you just mean this one side, right? But if I talk about the inside of my water bottle, that would not be area, that's volume. It's a three-dimensional shape. So that's why I don't like the word inside. But it is the inside of a 2D shape, but maybe a better way to phrase it is a covering, because covering always works, whether I'm in the 2D world or the 3D world. So it's the number of square units to cover a two-dimensional shape. And then actually it could be a 2D shape or a 3D shape. It doesn't even matter. Area is just the number of square units to cover a shape. Does that make sense?
Yes.
Okay, sweet. So now we are going to build on that knowledge today to find the area of what are known as composite shapes. So again, I don't like us to get started without knowing what the heck we're talking about. So composite is a common English word that we use. Like we have composers who compose music, or we have composite woods that they make. Composite gets used a lot in English. Do you know what that word means?
Like put together?
Exactly. That's exactly what it means. And that's exactly what it means here. When I say a composite shape, I mean a shape that's been like put together with other shapes. Okay. So it's a more complicated or complex shape, but it's been put together. It's built from simpler shapes, shapes that we know, known shapes. So we have a few shapes that we know on our GED formula sheet, right? We have rectangles and triangles, trapezoids, parallelograms, circles. In the world of area and perimeter, we have some formulas for that. So we'll do all our composite shapes built out of things on our formula sheet. We'll just use the ones on our formula sheet. Those are our known shapes. Okay, does that make sense?
Yes.
So I want to show you a couple ways that we could build a shape. There's basically two ways. Okay, so let's look at one example. I could kind of put shapes together, and I'll show you a very classic example. If you look at your GED formula sheet, there is no formula for an ice cream cone. You just won't find it. You know, you could look all day long and no one will tell you the area or perimeter of an ice cream cone. Okay, but I can look at this sucker and see how it's kind of built out of two different shapes. If I were to imaginary cut it right here, I can see how my ice cream cone is kind of built out of this shape. What kind of a shape is that?
An upside down triangle.
Exactly, it's a triangle. And the good news is there's no right way to put a triangle, so it doesn't matter if it's upside down or not. And then there's this shape up here, and then students say to me all the time, Kate, no, I don't know that shape. I'm like, yes, you do. You do know that shape.
It's like half of a circle.
It's a half circle, exactly right. And students are like, Kate, there's no formula for a half circle. And I'm like, no, that's because they expect that you know that if you have a circle, you could possibly cut it in half. So they just give you the circle formula. They expect you to do the math with it. Okay, so that's one way that they could make a composite shape. They could put shapes together. Okay, but they could also do one where you have shapes cut out. I've seen that too, so be aware. I'll give you an example of what I mean here. I saw one on a practice that a student was doing the other day. That was basically and I'm shading this shape here so you can see. But they basically asked questions about the shaded portion. So when they asked questions about the shaded portion, I said, oh, that's a big shape. Can you see what my big shape is here and pretend like I'm a better artist than I am?
A square.
Exactly. But it's a big shape that has some pieces cut out. And this particular one has 4 circles cut out. So that's the idea here. We can do a composite shape by sticking shapes together, or we could do a composite shape by taking a big shape, punching holes in it. Okay, so now for the rest of the class, you lucky thing, you're sparing a lot of lecture from me. I know there's students on the internet, by the way, who just forward to the first time I start a problem because you're like, Kate talks too much. But poor Serenity has to put up with the whole thing. But anyway, I'm done just talking. Let's go do some problems. Okay, I got a ton of different examples. First one, I chose to group these problems away for a reason. I put all the perimeter problems together. Mm-hmm. And then I put all the area problems together because what I've found over the years of teaching this lesson as much times as I have, that the problem solving for perimeter is very different from the problem solving for area. And students who go back and forth at first really tend to mix up which one's which. And so we're just going to do perimeter for a while solid. Then we're going to do area for a while solid. But I would consider both you, Serenity, and anybody else who watches this video, practice only perimeter for a while, then practice only area for a while, but eventually graduate to the level where you can flip back and forth between the two when you feel comfortable. Does that make sense?
Yes.
So let's first talk about how to attack perimeter problems. Let's talk problem solving technique. Now, we said that we know what a perimeter is. Perimeter is the distance around the outside. But we had also said way back on the very first day that we ever discussed perimeter, how to find the perimeter. Do you remember the easy way to find the perimeter of any given shape?
Use one of the formulas for the shape.
I suppose you could, and a lot of the perimeter ones do have formulas, but you don't actually have to a lot of the time with perimeter because perimeter is just the distance outside. It's like walking around the outside of the shape. So if I walked right here on this line, I would have walked 20 feet. Then if I walked on this line, I would have walked another
12 feet.
12 feet. Yeah. If I walked this line, I would have walked another 8 feet. Exactly. That's the idea here. Perimeter is like walking around the outside edge. And so it's just a bunch of lines added up. You'd walk 20 feet and, hear me say and, that means plus, 12 feet. And I'd walk, so you can always find perimeter by adding up all the sides. And that's really the problem solving technique that we'll use here. We will add up all the sides, but here's my warning to you, and this is the big warning. I just adopted a new phrase that I like so much, I've now said it 100 times in like the last 2 weeks. So this is my new phrase that I've decided to tell all students. The GED is not your mother. Okay, the GED is not trying to give you what you need. The GED often leaves out information you need to solve the problem. And so they will do that to you. So watch out for missing sides. We're supposed to add up all the sides. Watch out for missing sides. My students who get this problem wrong don't think about it. They just start. They tell me, oh, Kate, I remember that to do perimeter, you add up all the sides. And so they just start punching all these numbers in. They go 20 plus 12 plus 8 plus 34 plus 8 plus 7 is the perimeter. And it's not that they're wrong. It's that they didn't go all the way around. So let me show you what I mean. I have a 20. I have a 12. I outlined the 8 here. Here's the 34. Here's the 8. And here's the 7. But can you see I'm missing sides?
Yes.
Yeah, there's 2 sides that don't have a number there. Again, the GED is not your mom. They're not here to give you what you need. You need to go find what you need if you don't have it. So let's think about this. I'd say the easiest one to find is this one. The reason why I say that's easy is because I can see that this particular shape is composed of rectangles. Can you see it's composed of rectangles, Serenity?
Yes.
And I know something super important about rectangles. Here's a really important fact about rectangles that you have to know in order to understand these problems. Opposite sides of rectangles are congruent. That means they're equal. It's just the geometry word we often use for equal. So they're congruent, they're equal length. So I can see this rectangle. No, I don't know this side, but I can see the opposite side. Over here on the opposite side, I can see it's labeled 12. And so I know that that side also must be 12 feet long. So I'll label one of my unknown sides. And this is just really good problem solving. First, go and label all the sides before you start your addition. Make sure you have them all. So now I have that side. So now I'm only missing one side. And students do something very interesting. Students tell me the right number in this particular problem for the wrong reason. And so I don't want us to make a false assumption. A lot of students tell me, well, Kate, this has to be 7. And every time they tell me that, I say to them, why? Why? Because if you say it has to be 7, you better be able to prove that to me mathematically, not just like I have a good feeling about 7. So what most students tell me when I ask them that is they say, well, it has to be 7 because it looks like it's about the same length as that one over there. They look the same. And I say, oh, but are they opposite sides of the same rectangle? No, that's not enough evidence that this is 7. You cannot base your assumptions on looks in composite shapes. In fact, the GED will try to screw with you and make shapes that look the same when they're not. Okay, so let's see if this one really is 7 by testing it mathematically. Here's how we can do that. So let me erase that. Okay. So I'm going to use a different color now so you can really see what I mean. This is the unknown shape I'm trying to find. Do you agree with me?
Yes.
Well, that is part of a longer line, isn't it? It's part of this long line. And I know how long that total line is. Based on that opposite sides of rectangles are equivalent, I know how long that total line is. How long is that total line, Serenity?
Maybe 34, I'm thinking.
Exactly, 34. I look right to that opposite side. So I know this total distance has to be 34. But there's a few pieces of that total line that I don't want. I don't want this piece because I already have it accounted for. So we're going to need to take that piece out. Mathematically, how do we take a number away?
We subtract it.
So I'll subtract the 7 from my 34. I also don't want this piece. This piece is inside my shape. It's not on the outside, so I need to take it away. So if you want to know how long this one is, notice it's also a part of a rectangle. Look across to the opposite side.
Oh, 20.
Exactly. So that piece is 20. I need to take out that 20 too. So I'm going to take my total 34, but I'm going to take out the 2 pieces I don't want. I don't want the 7 and I don't want the 20. Let's do that mathematically. What is 34 minus 7 minus 20? And you can do it in your TI. And I actually do get 7. But that doesn't always happen. It's a coincidence, okay? But I proved it mathematically that it should be 7. Now I have all the sides around the outside, so I found the missing sides. So now I can go ahead and find the perimeter of this weird shape. To find the perimeter of this weird shape, I can just add up all the sides. 20 plus 12 plus 7. And I'll just say to the entire watching world that I know that some people come up with a shortcut to do this. And if you did, then I'm impressed. Plus 12 and 20 was my first one, so I'm done. Good, I got all the way around my shape. If it were me, I would make sure I just count my sides because some people just forget a side. That's a junk mistake to make. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I got all my sides. I'm good to go. I can do the ugly math in my TI. So here we go. 20 plus 12 plus 7 plus 8 plus 34 plus 7 plus 12. And do you know that if you make a mistake typing in your TI, you can delete just one symbol? You don't have to clear the whole thing. I see all these students clearing the whole dang row of numbers. I'm like, just arrow back and delete the one you didn't like. Okay, so P equals 108. And the question is 108 what? We've been talking about this for a while. Do you remember if perimeter is measured in linear units or square units or cubic units, Serenity?
Possibly linear.
Absolutely. It's just a line, so it's measured in linear units. You could take out a measuring tape and measure that way. And so it'll be 108 plain old feet. Plain old linear feet. So next one is very, very similar. Number 2 says find the perimeter of the composite shape on the left. Once again, I would warn you that since perimeter has you add up all the sides, that you would definitely find any missing sides first. Let's go over there to our composite shape and see what sides we have. So we have this side, that's a 3. I have this, that's a 4. I have this one, and I have this one, but blank side. Any thoughts on that blank side that I don't have, Serenity?
I'm thinking 10.
You're absolutely right. Since opposite sides of a rectangle are congruent, this one has to be congruent to that one. Beautiful. And now I see this one's 2. And now we're getting in a little more trouble. Now I have 2 blank sides. How about this next one here? So I'm going to start with this purple one just because it's easier. The top one's actually harder. Do you see that this purple one is part of a little invisible rectangle? Do you see that?
Yeah.
And so that means I can look at the opposite side. The opposite side is how long?
3.
3. So that purple side must be 3 as well. Okay, now let's do the tricky one that involves the 9. So this guy is also a 3 centimeter. Okay, so this last one is the trickiest one. Now, I agree with you that it's something to do with 9. If you look at the opposite side of this rectangle, this entire distance would have to be 9. Does that make sense to you?
Yeah.
But I don't have all of that entire distance. I only have this piece. So I'm going to need to take off the 2 pieces I don't need. This one and this one. Mathematically, we said if we want to take off a piece, we do what?
We subtract it.
Exactly. So I'll subtract out those 2 pieces. So how long is this piece? Right here on the left. Look at the opposite side. It'll tell you.
Are you saying 4 then, or the?
Yes, it's 4. Exactly. So I need to erase that 4. Okay. And now looking over here, I know how long this piece is too, based on its opposite side. This piece is
2.
Exactly. So I'm going to subtract out 9 minus 4 minus 2. 9 minus 4 is 5. Take away 2 is 3. So let me erase all my messiness. I just figured out that this piece here was 3 centimeters long. 3 centimeters long. I taught this to a class today. And I had about half of the students needing an aid, what's known as a assistive technology. So we needed an aid in order to be able to do these problems. And the aid was 2 different color markers. Seriously, I was like, here are 2 different color markers. And they used them over and over again so they could try to pick out the different side lengths. Anyway, if you struggle with seeing it, that can help you. Okay.
Yeah, that's why I've got my color-coded pens.
Perfect. Okay, so now I know all my sides. I have measurements on all my sides. So now I'm equipped to find the perimeter. So my perimeter, and I'll start with this one so I can keep track, is 10 plus 2 plus 3 plus 3 plus 3 plus, and again, if you have a faster way to do this, I congratulate you. 10 plus 9. But I'm just going with definition of perimeter, adding up all the sides. So here we go. 10 plus 2 plus 3 plus 3 plus 3 plus 4 plus 10 plus 9. 44. And this is perimeter, so it'll be plain old 44 linear centimeters in this case. Do you have your formula sheet with you?
I do.
Do you know what made me ask for the formula sheet?
I think it's the shape of it.
Yeah, exactly. You see that? I obviously do not know the length of that side. That is not part of a rectangle. The other parts are all rectangular, but that is circular. Anytime you have something circular, I don't care if you're doing area, perimeter, anything, you're going to need the formula sheet. Just like you could not take a ruler and measure a circle. Good luck measuring a circle with a ruler unless you have a very flexible ruler, okay? So same thing, I'm going to need that formula sheet when I get to a circle. So let's go ahead now and take a look at this. So of course, I'm going to ignore the circular side. Let's do that last. If I'm finding perimeter, as they asked me to do, I'm looking at the outside of this shape. So I need this length. I know that one. That one's labeled. I know this one. That one's labeled. This one's labeled. Uh-oh, this one's not. How long do you think this one is? It's part of a rectangle, so you can tell.
2.
Exactly. The opposite side is 2, so it's also 2. Opposite sides of a rectangle are congruent. Nice. I also know this little piece. This little piece here, after the 2, is a 1. So the problem, though, is that I don't know about the circular part of this shape. I don't. And I'm going to need a formula to figure out circles. Now let's think about this. We're doing the outside edge. It's a perimeter problem, so I just want the outside edge of the circle. Do you remember the special name for the outside of a circle?
I do not.
It's known as the circumference.
Oh, okay.
Circumference. And in fact, if you look at the perimeter section of your GED formula sheet, you'll notice that the circumference of a circle is in the perimeter section. And this is why. Circumference is the special name for that outside of a circle, or that line around a circle. But this is not a full circle, is it?
No.
You're right that this is a circumference of a half circle. And so that is exactly the math that I'm going to do. I'm going to do half of the circumference of a circle. Can I say that again? I'm going to do half of the circumference of a circle. So the formula sheet tells us how to find the circumference of a circle. There's two formulas on there, and I'm actually going to pick C equals pi d. And I'm about to show you why I'm about to pick C equals pi d. But the reason why I was thinking to choose the one with D in it is because I can see this line. This little blue piece of a line that I drew in here is the diameter of this circle. Imagine this circle drawn all the way fully. That would go across the circle, and that would be its diameter. I don't want to mess up your sheet, but this is what I'm asking you to imagine, that circle went all the way around. You could see that line there is a diameter. Even though I don't have that number right now, I have enough information to figure out that number because that line is on my circle, but it's also a part of my rectangle. Can you see that? And I know that super important thing about rectangles, that opposite sides are congruent. So if this side is 7, this entire length is also 7. Yes, but there's two pieces of that length that I don't want. I don't want this piece, and I don't want this piece. They're outside of my circle. So to find this radius, I'm going to take that 7 and I'm going to subtract out the two pieces I don't want, the 1 and the 2. So 7 minus 1 minus 2. And I don't know why I'm doing that in a TI because that is 4 centimeters. So the diameter of that circle is 4 centimeters. I now have the power to find the circumference of this half circle. So let's start with just finding the circumference. So C equals, and I'm going to plug in 3.14 for pi because I do have some rounding directions. And my diameter is 4. So C equals a 3.14 times 4, and I get 12.56. But we need to be really, really careful here. We need to be very careful because circumference is meant to give you, this formula here is designed to give you the circumference of a full circle. We just found the circumference of a full circle because that's what the formula does. Mm-hmm. Do we have a full circle?
No.
No, we only have a half a circle. And students say, Miss, I don't know what to do. And I'm like, you don't know what to do? We're going to half the circle. That's what we're going to do. Half circle means half the circle. So I'll take half of the circle's circumference. There's a really quick, easy way to half something in your calculator. Just divide it by 2. So to find my half circumference, and when I write half C, I'm not telling you to do something with C, okay? I'm just literally being too lazy to spell out half of the circumference is. So I'm just writing it like that because I'm a lazy mathematician. Half of the circumference is, and I'm going to take my 12.56 and I'm going to half it. And one way to half something is to divide it by 2. 2 equal pieces is cutting something in half. And so I will put 6.28. And so that means that this arc here that I did not know is 6.28 centimeters long. Now I have all the information I need to add up the perimeter. But be careful because I actually have a number here that I don't need anymore. Even though it's on my shape, it's not part of the perimeter. Do you see it?
4.
Exactly. That 4 is inside the shape. Now I needed it because it got me where I wanted to go for the outside of the shape. So I needed it before, but I don't need it now. It's not part of the outside. So now I go to add up my perimeter. I'll add my 6.28 with my 2, my 2, my 7, my 2, and my 1. 2, 2, 7, 2, 1. I should get 20.28. Now I'll round as directed. So I'm to my final answer, so you never round until you're to your final answer. What do my rounding directions say? What place did they want me to round to? Nearest hundredth. Hundredth is how many decimal places?
2.
Absolutely. How many decimal places does my number have right now?
2.
My answer here that I'm looking at?
2.
Exactly. Hundredths is 2. I've got 2. Guess what? It's already rounded. Don't fix it if it's not broken. Students spend all day long trying to round something that's already done. Okay, so 20.28. So all I need now is a unit if I don't need to round. So my unit here would be, of course, plain old linear centimeters. I have so many students who are so scared not to round that they'll round that to a different place just to make sure that they were obedient. But yeah, it's already stopping at the hundredth, so I'm good to go. Woo! Tricky, definitely challenging. We're really putting together all our definition and our knowledge about perimeter and area with some mathematical reasoning. And that's the kind of problems you're most likely to see on the GED. They're not testing if you just remember a few steps your teacher taught you. They're really testing to see if you understand. And so I expect to see things like this come up. So the GED sent adult educators a list of problems maybe 2-3 years ago that they called the most commonly missed GED problems. I think we talked about this last class as well, but they gave us the problems right from the test. They must not be in use anymore because they won't give you problems that are in use, but the exact problems wouldn't be in use. But they gave us the problems right from the test that students had missed the most on the 2014 test. And this is one of the ones they sent me. Now I took it and I changed up the numbers, okay? So you won't see these exact numbers on your test, but this is a concept that you might see on your test, okay? So number 4 says find the perimeter of the composite shape on the left, and round your answer to the nearest tenth of a centimeter. So again, I've been asked to find perimeter. I know that perimeter is the distance around the outside. And I am a little disappointed because none of the numbers on the outside of my shape, none of the outside line are labeled. Every single measurement I see, in fact, is an inner dimension of this particular composite shape. And I need the outer dimensions for perimeter. Can you help me? Like this outer dimension, how long would that be?
I'm thinking 7.
You're absolutely right. Opposite sides of a rectangle are congruent. So if that one's 7, the other one's 7. And this one even is a special kind of rectangle. Maybe you know it. We can see all the sides are congruent, so it must be a square. So same thing here. How long would this piece be then?
7.
Also 7. So those pieces were relatively easy to figure out, those outside pieces. The tricky outside piece, of course, is, I need a totally different color here. There we go. This outside piece. Now that's challenging. What kind of a shape is that?
A circle.
Yeah, it's a circle, but it's, again, a partial circle, isn't it? How much of a circle is it? And this is what students struggle with.
I think it's like 3/4, right?
You're absolutely right. It's exactly 3/4 of a circle. And I'm so glad you said that. A lot of students would struggle to see that, but you're absolutely right. If I broke that circle into quarters, I've got 1, 2, 3 of them, and the 4th one is missing there. So I can literally find 3/4 of the circumference of a circle. I can do that, and that's exactly what I'll do. First, I'll find the circumference of a circle. You don't necessarily have to do this first. I just find it's more easier for most students to understand. And then when I'm done finding the circumference, don't let me forget, because sometimes I like to forget Serenity. I'll take 3/4 of it, okay? So here we go. Circumference of a circle, we said was pi d, but it's also 2 pi r. And I'm going to use 2 pi r. Can you see why I wanted to use 2 pi r this time? It's actually because I know r. It's actually because I know r. Do you see r here? Remember that r goes from the center of a circle to the outside of a circle. So r was that known length that they gave me. So since I know it, I might as well use it. So I'll do 2 times 3.14 times r, the radius is 7. And you're going to help me remember not to forget to take 3/4 of it. So 2 times 3.14 times 7. So I get C equals 43.96. Now is when my students panic. They say, how am I going to take 3/4 of something, Kate? I have no idea. You never taught me fractions. Well, the great news is your calculator will handle fractions as long as you know what it means to take 3/4 of. To take 3/4 of something, the word of literally means multiply. You can translate it as multiply. You can take 3/4 of 43.96. I just talked about this in a GED forum on Facebook yesterday. A student was telling me, Kate, I thought I didn't need to know fractions for the GED. And I'm like, you know what? You probably don't. But you do need to know what I mean when I say of, so that your calculator will do the fractions for you. And I can type 3/4 into my calculator using the N over D button. So I'll type 3 N over D 4, and then I'll open up my parentheses and put in my answer from before, 43.96. And I find out that 3/4 of my circle is 32.97, which means this whole long yellow piece is about 32.97 centimeters long. That was tricky. Again, none of these problems are that hard, but they do require logic and reasoning and planning. Planning is scary for a lot of students. Okay, so my first thing I did, I got all the sides. Can you see that now all of my sides on the outside are labeled?
Yes.
Now I have what I need to find the perimeter. So find any missing sides first, then find your perimeter. So my perimeter is going to be adding up all the outside sides. So careful, these guys are in the inside. I don't want them. But I do want the 7, the other 7 that are on the outside, and the 32.97. So I'll just add 7 and 7 in my calculator to what I already had, and I'll find out that that total perimeter is 46.97. Now comes the final part. The final thing we do is rounding. So we're going to round our answer to the nearest tenth of a centimeter. Do you remember where the tenths place is, Serenity? How many decimal places is that?
1.
1, exactly. So I am going to chop off my number after the 9, but I have to consider the number I'm about to throw away, the 7, and ask myself if it's big enough to matter, right? Anything 5 or higher is big enough to matter, so it's going to bump this number up. Now, something super interesting happens here. I had 46.9. I can't go up past 9 in my digit system. And so it's important to think of this as a whole number like 469 in order to bump it up, because it's going to go all the way up to what we think of as like 470. Now, my decimal place will stay where it was, so it's really 47.0. Students get mad at me for this. They're like, Kate, why don't you just drop that 0? We usually drop zeros after decimal places. They don't matter. And I am leaving that 0 right now to tell you, to tell everyone who looks at my problem, I did round to the 10th place. I got a 0 in the 10th place when I did. So I get 47.0 what? 47.0
centimeters.
Exactly. Woo! Tricky, tricky. So number 5 says, find the perimeter of the composite shape on the left. And FYI, I threw some numbers at you that you don't need here. For this particular problem, we'll need them later on another problem, but it says find the perimeter of the composite shape on the left. The composite shape that I'm looking at, I don't know, it's like a house.
Yeah.
But anyway, to find the perimeter, I just need the outside sides, right? So I can see some of them. I see this one, 18, this one, 20, 15. Problem, I don't know this one. What do you think it is?
15.
You're right. Now, though, I have to ask you why you think that, because most students are wrong. Why do you think it's 15? What tells you that it's 15?
There's that dash on the other side.
Bingo, you're not wrong, Serenity. That's what we use in geometry to say congruence. We're too lazy to tell you the two sides of the triangle are congruent. It would take forever to write. And so we just put little dashes on the shape to show you those two sides are the same. So nice. Good job. Cool. And then I'm just missing this side now. How long is that side?
It says it's supposedly 32, but I think that 32 is not necessary.
Yeah, it's not 32. 32 is from the floor to the roof of my thing, which is not part of the perimeter. So, but I do have enough information to figure out that missing piece. Do you see where I can see it?
I believe it's the 20 possibly.
Exactly right. The bottom of this composite shape is a rectangle, meaning opposite sides are congruent. So if that side's a 20, this side is also a 20. Beautiful. So you don't have to know a lot about geometry to pass the GED because of the formula sheet, but you got to understand rectangles. Okay,
Right.
so now I can add up my perimeter. This one's easier than the rest. I should have put this one in the middle. 15 plus 15 plus 20 plus 18 plus 20. All my sides. And notice I didn't take any of the inner dimensions. I didn't bother with the height of the house because it's not part of the perimeter. 15 plus 15 plus 20 plus 18 plus 20. I should have spoken complete math sentences. The perimeter is 88 and 88 what? 88. So just a brief synopsis before we move on, because like I said, the biggest thing that students mix up is what to do with perimeter and what to do with area. So if I'm finding perimeter of a composite shape, the first thing I do is I'd find the dimensions, any missing dimensions. And I shouldn't say any missing dimensions. I should say any missing sides on the outside, because it's only the outside we care about for perimeter. And I'll remind you that those can even be circular ones, halves, circles, quarter circles, or I suppose even a full circle, but even circles. And then 2, once we're done, we'll add up all the outside sides. Okay. So general problem solving when I go for perimeter.